Section 3 Scale Factor, Example 2. Pete is building a new barn. The table below represents its actual and scale measurements. So we have our actual measurements right here and our scale measurements here. Think of a smaller scale object that represents what he's going to build. They go by that structure, that little model to help build the bigger one. But they have to have things proportional. So in this case, they show that 4 inches on a scale drawing represents 16 feet in actual building size. Now there's one thing that you have to be very careful with here, and that's to interpret the units. Notice that in the scale drawing, it's in inches, and in the actual length, it's in feet. Now that would make sense because the object that's actually going to be built is going to be bigger, but you have to be careful when we make proportions. The units have to be the same. So just for exercise here, I'm going to convert 16 feet to inches. Well, there's 12 inches in 1 foot, so 12 times 16 is 192 inches. 25 feet, again, 25 times 12 would give us 300 inches, and 10 feet would be 120 inches. And that's going to come into play later because our units have to be the same for us to solve. So our first question says, what's the length of the water line in his scale drawing? Well, we don't know it. Well, these objects are proportional. So I can choose a comparison here. If we go with door opening, I'm going to choose to use four inches on a scale drawing is equal to 192 inches of actual length. Well, we're going to use that ratio because all objects have to be proportional. And we're going to make another one and say, well, you know what, I don't know the window or the water line length on scale, but I do know that in the actual building it's 120 inches. And there's our proportion, which we talked about. We saw by cross multiplying. When we do so, we get 192x equals 480, which is 4 times 120. Divide by 192 and we get 2.5 inches. Remember our units. And that is the length of the water line in the scale drawing. B says, if you recorded a scale length, okay, read the words carefully, scale length of 5 inches for a window, what's the actual length? Now the nice news here is that we can continue to use the same ratio every time. So I'm just going to go ahead and use 4 over 192 again. But I have to remember what information I'm given and what I'm looking for. Again, in this case, they give us the scale size. So remember, the 4 represents the scale drawing, so I have to put the 5 above. Actual length is the bottom, so I have to have that be the unknown. Don't get those mixed up, otherwise it will mess up your calculations. Cross multiply, and we get 4x equals 5 times 192, which is 960. We divide both sides by 4, and we get 240 inches. This next question has us compare a calculation and check it. If he measures the actual window to be 3.75 feet and recorded a scale measurement of 0.85, is he accurate or not? Is it correct? Well, we know there's two things we're going to do here. One is I have a ratio of 4 over 192, and that's the same for every comparison. If I'm going to check that, I want to write down the ratio they give us, which is 0.85 for the scale, but I can't use 3.75 for the actual because that's in feet. So I'm going to have to take that times 12 and get the unit in inches, which is 45 inches. So I put 45 down here. Now if these are proportional and everything is good, the cross products will be equal. And if I cross product this, I get 180 equals 163.2. In other words, 4 times 45 is 180. 192 times 0.85 is 163.2. So, no, this is not accurate. Another way to check it is to just actually do the division of this ratio. And if you did that, you get 0.0208. If you do this one, when you divide the two of them, you get 0.019. They should be equal, and they're not. So that's another way to show that they are not equal. What's the scale factor used? Okay, well, this one, we have to watch the direction here very carefully. Actual to drawing. So we have to take the actual one, and again, if I take, let's say 4 is the inches of the drawing, and 192 is the building, we would say 192 to 4. Now, when we say scale, we typically want to simplify, though, as we talked about with bagels and so on. So if we do that, we can simplify that down to 48 to 1. And that can be written as 48 over 1 or just 48 to 1. Either one is fine. And I would say a scale factor then is the same as a ratio. And this ends section 3 scale factor on example 2.